Hello, my name is Quinn Murphy, and I'm going to be doing the test wrapper for exam 1 and going over the third question. So, I don't know if you have a copy of the question in front of you, but I'm going to have mine here as well as a couple other pictures that I drew to help me explain it. So the first thing that you're given is, you read the question, a charge Q, negative 3 times 10 to the negative 9th coulombs is placed at the origin. Calculate the electric field EQ1 at point A, which is located at position 1.1 in the x direction, 0.1 in the y direction, and 0 in the z direction. So the first thing that you do is you're going to want to find your r vector, and that's observation location minus source location. So in this case, the vector that's given, the 1.1, 0.1, and 0 vector minus the source, which in this case is the origin. So you use that and you go ahead, you can find, so that is your r vector, and then you want to go ahead and take the magnitude of that and then find your unit vector. So the unit vector is just the r vector divided by the magnitude vector. And then you're going to want to use the electric field formula for a point charge, and in this case it's E vector with the half arrow symbol on top equal to 1 over 4 pi epsilon naught times Q over the magnitude of r hat, or r vector, squared times r hat. So that's why you need to find the r hat and the r vector. So moving on to the second part is talks about polarization with a metal cube, which is a conductor. So if you can see here, the electron is right here and it's got the charges coming towards it from all directions. So in that case, because the metal cube is a conductor, it brings in all the charges, or the positive charges or parts of the metal box are attracted to the electron, so it causes a polarization. So as you can see here, there's positive charges drawn closest to the electron and negative charges over on the other side. So that's part 2. Part 3, or part C I should say, is calculate the electric field due to the charge EQ2 due to the cube E cube 2, and also the net electric field E net 2. So you're going to start this one off the same way. You're going to want to use the observation location minus the source, and you're going to use the same electric field formula. So what I forgot to mention in the first part, which is also valid for the third part, is you want to use the Q that you're given. So not the Q of the electron, which is typically 1.6 e to the negative 19, but in this case you want to use the negative 3 e to the negative 9. So you can factor all that out, figure it out, and it works out the same way as number 1. Not the exact same answer, but the same process. So moving on to part 4. So part 4 is the same as part 2, except this is an insulator that this electron is by. So what we want to do here is set up the same thing, and again, I tried to draw it out here to see a little bit better, but you have this electron here, and as you can see, all the charges are coming towards it. But because it's an insulator, the plastic cube is not a conductor, then you know that the electrons can't move freely. So instead you have individual molecules polarizing, or molecules within the plastic part polarizing. So it's not the entire molecule has lots of little pill-shaped almost symbols where, again, the positive is leaning towards there, but it doesn't have the same freedom to move as an electron. So after we've drawn that, then the next thing, the last question asks, is rank the net electric field magnitudes at location A. That is, what is the order from smallest to largest of E net 1, E net 2, and E net 3? Excuse me. So what this is testing essentially is it wants to know if you know that the net electric field inside a conductor is 0. So it is 0 anytime that you're on the inside of a conductor. The net electric field is 0. So that makes E net 2 0, and that's going to be our smallest one. E net 3 is is the one dealing with the insulator, so that one's going to be less than if it was just a regular conductor, or outside of any point, because an insulator is less effective than a conductor and less polarized by the charge. Like I said or showed earlier, it's just these little pill shapes, so individual molecules are polarized, and then that leaves E net 1 as your standard and largest electromagnetic field. So thank you very much for your time, and that's question 3.